Controllable nuclear fusion has been hailed as the ultimate energy source for human civilization. But in fact, it's far from being the ultimate, because its smart conversion rate is only 0.7%. The conversion rate of antimatter is 100%. So to physicists, antimatter annihilation is the real ultimate energy. He can turn all mass into energy and release it. It can bring Einstein's formula for intelligence to the highest level. Compared to smoke-extinguishing energy, controllable fusion is a candle. So in science fiction, antimatter is commonly used as a source of energy for bombs or spacecraft. Unfortunately, at this stage, human civilization does not have the ability to produce antimatter. In the case that only a small number of antimatter particles can be produced inside the particle collider, 1 gram of antimatter costs up to $60 trillion to produce. So in the future, we can meet antimatter cannot be used as energy. However, research on antimatter has been ongoing. There was an article in Nature recently that said, physicists validate the validity of Einstein's theory in the field of antimatter. That is, it is clear that antimatter can also be affected by attractive forces, and there's no reaction force. Specifically, what they've observed is the free-fall motion of some antimatter particles, confirming that antimatter is just as susceptible to the Earth's attractive forces as normal matter. It's just that they have the opposite charge to normal matter. Substances in our daily lives are negative electrons or politics. And antimatter is the positron or replicon. Once they come into contact, they instantly drown and release energy. Therefore, the preparation of antimatter is carried out by electromagnetic force. In fact, behind the antimatter, there is also a cosmic secret hidden. According to the Big Bang universe model, when our universe exploded 1380 billion years ago, in fact, it produces equivalents of matter and antimatter. In theory, these substances should be completely annihilated. Release it all in the form of energy. But in fact, our universe has left behind some positive matter. And it went on to form stars, galaxies, and us here on Earth. After this Big Bang, the mismatch between true matter and antimatter, it's called symmetry breaking in science. And so far, we don't know why there's some real matter left behind. Some scientists even think that at the moment of the Big Bang, there was nothing else in our universe. It also formed an antimatter universe. And in their eyes, we are antimatter. This experiment also proved that the acceleration of antimatter particles and antihydrogen atoms under the attractive force of the Earth is the same as that of ordinary matter. This means that the natural antimatter gate in the universe will also be affected by the attractive forces of other celestial bodies. There's no anti-attractive force or anything like that because of the properties of antimatter. In the foreseeable future, the development and utilization of antimatter will definitely become a reality. Because its energy density is too high, it belongs to the top level of intelligent transformation. There will be no more energy released in the entire universe than the annihilation of positive and antimatter. So if future human civilization can produce antimatter, it only takes the energy of a few antimatter particles to fly a spacecraft from Earth to Mars. We also need to recognize that 1/2 ton of antimatter exploded on Earth can shake the deep geological structure of the Earth, even let the whole Earth disintegrate. So the risk of developing antimatter is as great as the risk of antimatter. Just like today, we are developing nuclear energy while guarding against it. What is the largest structure in the universe? Not the diameter. 200,000 Milky Way, or the Laniakea supercluster 520 million light-years in diameter. It's a cosmic wall that stretches 10 billion light-years. When several cosmic walls spread out across the universe, when staggered, forming the topmost structure, and cosmic network of the observable universe. Because this structure closely resembles the distribution of nerve cells in the brain, so astronomers call them cosmic neural networks. And then there's the idea that the universe is a brain. For a considerable period of time before, cosmic neural networks are limited to theory. Because his scope is too large, the light is too faint. It's essentially a network of millions of galaxies, which has always been very difficult to photograph. But not so long ago, a group of scientists at the California Institute of Technology announced they captured glimmers of light from cosmic neural networks. They selected a region of time and space 1050 billion light-years from Earth, 1,000,000 light-years away, deep 600 million long exposure of galactic networks within light-years. Then used the radiation from distant quasars and the light from bright galaxies. Sketches part of the entire universe of neural networks. This is what we see here. From the spectral information, the main element of cosmic neural networks is hydrogen. This is consistent with theoretical predictions, because the network itself is made up of galaxies. Galaxies are mainly made of hydrogen stars. For example, the Sun and hundreds of billions of other stars make up the Milky Way galaxy. And the Raniakaya supercluster, where the Milky Way is located, is a relatively large node in the network structure of the universe. Now you might be wondering, how did this structure form in the universe? The current theory holds that 1380 billion years ago, the Big Bang, then about 60% of the hydrogen collapsed into a thin film in three-dimensional space-time. The hydrogen in this film is collapsing under attractive forces to form stars and galaxies. And as the number of galaxies increases, and the film starts to thin out, and it's moving towards a network of lines. 039. The average person may marvel at the grandeur of the cosmic network, the sheer number of galaxies, but astronomers are more concerned with the dark parts of the fabric of the cosmic network. Because it holds the biggest secrets of the universe in dark matter and dark energy. The current theory of cosmology holds that all the matter that can be seen in the universe, that is, galaxies together make up only about 5% of the mass and energy of the universe. And the remaining 25% is dark matter. 70% is by energy. Because dark matter cannot be seen, existence can only be confirmed indirectly by attractive force. So scientists keep saying that the universe we see is only 1/20 of the real universe. The remaining dark matter and dark energy are hidden in the dark parts of this image. And voids in the cosmic network. It's where dark matter and dark energy meet. They do the exact opposite. One could even say, dark matter and dark energy have been shaping the fate of the universe. Why do you say so? Because dark matter provides an additional attractive force. Make sure the galaxies don't fall apart. And press energy has been providing extra vision. Let the universe accelerate its expansion. The universe is expanding faster than the speed of light. Astronomers believe that if acceleration is suppressed by energy, eventually it will tear apart the fabric of the cosmic network, make galaxies lose touch with each other, as isolated individuals in a larger and larger universe. In the final stages of cosmic expansion, all stars in all galaxies will be torn apart. Even every atom will be torn apart. And the end of the universe is the Big Rip. Astronomer Herschel was the first person to notice changes in the brightness of Sensu Temple, because compared to the general rampage, the brightness of Sensu Temple will suddenly rise and fall in a short period of time. At that time, there was no concept of a supernew drama breaking out, so Herschel in 1936 had no idea that what he had discovered was a missile that was ready to explode. even red supergiants that have erupted. I don't even know that his explosion could bring about the annihilation of human civilization on Earth. All he could do was tell posterity to pay attention to the star. Today in the 21st century, with the help of the Hubble telescope and the Scarf telescope, astronomers have learned more about Betelgeuse. Although hundreds of years had passed since Herschel noticed him. But on a cosmic scale, hundreds of years is just a flash of a finger. So the Sangsu temple we see today is compared to the Sangsu temple of the past. The overall situation hasn't changed much. Brightness is still unstable. It could still explode at any time. In fact, historically, ancient astronomers noticed changes in Sangsu temple before Herschel. But people generally do not believe that meat can also observe this. So the ancient astronomical record was shelved. Until Herschel noticed the light change in Sangsu temple. People just realized that Sangsu temple has been unstable for a long time. So here's the problem. The known Rust 4 is 640 light-years from Earth, when he himself may explode with super clarity at any time. Will he have any impact on the Earth? First of all, we need to clarify the time difference. That is, whether it is the ancients thousands of years ago, or Herschel hundreds of years ago, and now all we see is never the real-time state of Sangsu temple. It's what he looked like 640 years ago. This means that if Sangsu temple erupts now, we won't find out until 640 years later. And if the next second a star several times brighter than the full moon suddenly appeared in the direction of Sangsu temple, then it means that Sangsu temple broke out 640 years ago. Now in the second half of the night Sunny Wu Yueye, anyone can see Sensoji on Orion's left shoulder with the naked eye. It's visually redder than even Mars. This means that the hydrogen fusion inside him is about to run out. And here we see the last of his glory before he explodes. If we are not wrong about the quality of Sangsu temple, in the future, it will erupt several times brighter than the full moon, and it will last at least a few months. This means that in the months following the outbreak of Senseo Monastery, the night on Earth will be bright. At least the streetlights don't have to be turned on anymore. When Skybuster exploded in 1054 AD, the readers of the Song Dynasty could read books with the help of superstars without lighting lights at night. But in addition to the extra light, Betelgeuse may also bring other things to Earth, such as radiation far exceeding the sun, the kind that is so powerful that even the Earth's magnetic field cannot resist. Although the astronomical community generally believes that the distance of 640 light-years helps attenuate the radiation of Sangsu temple to a level harmless to life, but 640 light-years away, no one can be completely sure that rust is harmless. And in theory, due to the instantaneous release of energy by a supernova in the old age of a massive star, equivalent to the sum of the past few billion years, so its radiation is generally far beyond the range that life can bear. Just like bacteria can't withstand a sterilizing lamp. In general, although the current state of Sangsu temple is unstable, but as long as human civilization is given a window of development, like hundreds or thousands of years, human civilization would have a more detailed preparation plan for the possible eruption of Sensoji temple. At that time, even if it does explode, it will not affect human civilization. Einstein believed that time did not exist. The way we perceive time is just an illusion of the brain, and the speed of time is different for everyone. In chivalrous relativity and general relativity, the speed of time is affected by the speed of motion of the object and the strength of the attractive force field. This slows down time. The typical thing is that the faster the speed, the slower the time. Reaching the speed of light, time stands still and slows down near a black hole. So this has been proven. And this also explains that time is one of the most fundamental physical properties in the universe. It's not that impressive. To be precise, time is a part of the universe, rather than an absolutely objective existence independent of space. This means that if the universe undergoes a special change, time can change or even not exist. At least in the current theory of physics, time did not exist at the beginning before the Big Bang, nor at the beginning of black holes today. And the future cosmic collapse or end of the world is mainly related to the end of the universe. Astronomers believe that if the current rate of expansion of the universe had not been misestimated, and according to the proportion of energy, it is about 70%, the accelerating expansion of the universe will only get worse in the future. And as a result, the large structures in the universe will be gradually torn apart by the forces of cosmic expansion. From superstar clusters to galaxy clusters to clusters of galaxies are not lucky late. The forces of this cosmic expansion will gradually be distributed to the solid structure. For example, the Milky Way will rest when the solar system is torn apart. The solar system will fall to the Earth and be torn apart. Less. The Earth and even every atom on the Earth will be torn apart by the forces of cosmic expansion. The entire universe will come to an end called the Big Rip. When there is no matter in the universe, time would cease to exist. Except for the Big Tear, the reverse contraction of the universe is also a phenomenon that could cause changes in time. Because some physicists believe that the current direction of time is related to the expansion of the universe. If the universe were to shift from expansion to contraction at some point in the future, then the flow of time will also change. Time may flow in the opposite direction. This idea appeared in Liu Cixin's Greed. Eventually, the contraction of the universe caused time to start flowing in reverse. Yesterday becomes tomorrow. The entire universe begins to evolve into the next Big Bang. As for whether time really exists, some theoretical physicists and philosophers have argued that time may just be an illusion constructed by our brains to understand and organize the events around us. In some physical theories, time is seen as a convenient mathematical tool. Rather than the fundamental properties of the universe, the pursuit of reconciling relativity with quantum mechanics has led physicists to new theoretical frontiers. Quantum attractive force. The goal of this effort is to develop a framework can describe the behavior of the universe at its most fundamental level, including the behavior of time near the starting point. Some theories suggest that instead of the starting point, the black hole's core or the universe at the Big Bang could be a quantum bubble, where space and time are so turbulent, so much so that the classic concept of time no longer applies. In general, exploring the challenges of time transcends the limits of human knowledge and imagination. It forces us to confront the fundamental nature of reality and our place in it. Will time really end? Or will he continue to haunt us with his mysteries? It remains one of the most profound questions in science and philosophy. There are two concepts in cosmology that have attracted a lot of attention in recent years. They are undercurrent and giant shadow. But what is an undercurrent? What is a giant shadow? Will it have any impact on the universe? Undercurrents refer to the large scale of the universe. Many galaxies seem to be moving in a particular direction. And this kind of movement doesn't seem to conform to the universal laws of the expansion of the universe. In 2008, scientists first observed this phenomenon. That is, after removing the interference of the expansion of the universe, a large number of galaxies tend to follow the same trajectory. This flow is called an undercurrent, because it just seems like an unknown source of attractive force that we can't directly observe. The filmmaker is located in the center of the observable universe region. superbody structure of unknown mass. He generates a powerful profit for the surrounding galaxy, causing these galaxies to move towards him. Back in the 1970s, scientists have noticed our supercluster appears to be being attracted by a large attractive force. However, since the filmmaker is in the shadow of the Milky Way galaxy, so it has long been obscured by stars and interstellar dust. Astronomers cannot directly observe the filmmakers. With further research into the undercurrent, scientists began to suspect that this cosmic scale flow might be related to the source. Although the original hypothesis suggested that the entire universe might be moving towards a giant source, but later studies have shown that this flow is more likely to be found in the local universe, a phenomenon of year 2013. Data from the European Space Agency's Planck Space Telescope have failed to confirm the existence on cosmic scales. But this doesn't mean that the concept of undercurrents has been completely overturned. Undercurrents remain an important area of research. He may have revealed some new laws in the structure and dynamics of the universe. On current structural studies on the scale of tens of billions of light years, undercurrent and filmmakers are always two key nodes that cannot be avoided. Astronomers hope that by studying them, they can gain a basic picture of the observable universe and even the entire universe. After all, the Milky Way is just a drop in the ocean of the universe. Studying the Milky Way won't do much to restore the face of the entire universe. After the photo of the Hubble factory was released that year, astronomers generally believe that galaxies are evenly distributed across the observable universe. Just start from the Earth. No matter which direction you look, they all end up with the same number of galaxies. However, this principle, called isotropy, does not hold true on large scales. Because in the structure of the cosmic Great Wall above superclusters of galaxies, galaxy gates are not uniformly distributed. It's distributed in chains. Galaxies are densely distributed at the nodes of the Great Wall of the universe, and the nodes of time in the galaxy are relatively sparse. Sometimes they are separated by a cosmic void. There may not be a single galaxy inside the void. However, the network itself is currently being pulled by the faster-than-light expansion of the universe. It may break into smaller structures in the future. Even the giant shadows in the undercurrent future may cease to exist. Because the accelerating expansion of the universe will eventually tear apart large-scale structures. For example, in the future, the giant shadow crew will be torn into smaller structures. The undercurrent can also be broken. Eventually, atoms in the universe might be torn apart. This is the end of the Big Rip universe. In general, although the mystery of the undercurrent and the filmmakers has not been fully solved, but they have become an indispensable part of modern cosmological research. With the continuous advancement of observation technology and the continuous improvement of theoretical models, we have reason to believe future research will uncover the secrets behind these cosmic phenomena